Okay, question 5 part B. The programmer uses a compiler to translate the computer program. Describe how the compiler translates the computer program. So in the stem of the question, we know that a computer program was written using high-level language. We know that humans, here at the top of the mountain, we like high-level languages because they're written much more like the natural language that we speak. But the computer doesn't understand that, so the code we write into high-level language needs to be converted into the ones and zeros into machine code, and that's what we need translation software for. So there are two types of translation software to convert a high-level language into a low-level language, and those are a compiler, which is the one in the question, and an interpreter. Now, interpreters work differently to compilers, but they do the same thing. An interpreter will take the original code, the program, and it will convert one line. It'll execute or run that line, and then it'll convert the next line. So it does it one line at a time. Whereas the compiler does the whole thing in one go. So let's try and pick up some marks then for how a compiler works. So a compiler converts all of the source code. Compilers convert all of the original program, you could say, but we also call it source code, into, and generally the file that the compiler creates is called object code. So compilers convert all of the source code into object code in one go. So it does it all together. I'm also going to add, let's say, this happens before any code can run. Whereas with the interpreter, the first line is interpreted and it's run or executed. Then the next line of code is interpreted and executed. Whereas with the compiler, we do the whole thing in one go. Right, so let's have a look. Compilers convert all of the source code into object code in one go. This happens before any code can run. And we end up with a file that we can take to any computer and run. But the condition is that the compiled file that we have, which we call an executable, it is designed to run on a particular operating system. So you need different compilers to compile source code for different platforms, if you like. So for Apple, Android, Linux, etc. So let's just put something along those lines here. So an executable file is created which will run on a specific operating system. Okay, so that's what we end up with. So compilers convert all the source code in one go, in one pass, and no code runs before this can happen. And we end up with an executable file which will run on a specified or specific or particular operating system. There's lots we can say about how errors are handled, but I've noticed that that's what we need to do for part 2, so I'm not going to tackle that yet. So let's have a quick look at the mark scheme for this one. So it translates the high-level language into low-level language, object code, machine code. So we talked about converting the source code into object code, so I'm happy that we're going to get that one. You can also call it machine code, low-level language. They're happy with anything there. Translate all the code before it's executed. So we have said that. So we have said that this happens before any code can run. So we have stated that that happens before any code is executed or run. That's fine. We've said that. And then finally, we've said it creates an executable file, but we've also given a little bit more information, the fact that this executable file will only run on a specific operating system. So let's stop this one here, and then we'll just do this last bit as a separate video. Thank you very much.